So we have probability distribution, and they've given us these questions. This is our background information, and we'll pull the question out of it. The door prize at a raffle consists of 4 $10 coupons, 5 $20 coupons, and 3 $50 coupons. And the question they're asking us is, let's say they want us to show all the options, and we'll assume this is all drawn at random. It's thrown in a bag, and you're kind of just pulling names out of a hat here. What are the probabilities? So what are the probabilities of the first two draws? Okay, so we'll call it draw 1 and draw 2. Okay, what does that mean? Well, the very first thing we need to do is figure out our probability, our p at x, which is equal to the idea of 1 over n. So we need to find out n. How many possibilities are there? Well, let's go on the assumption that if it's door prizes, that everybody's going to win. Okay, so how many prizes are there? Well, there's 4 $10, 5 $20, and 3 $50. So I'm going to kind of put that on the side and then add them together. So we have 4 $10, we have 5 $20, and then we have 3 $50 coupons. Okay. Well, the total number of coupons is the addition of all of the door prizes here. So 4 and 5 is 9 plus 3 is 12. So there are n 12 options. So a 1 in 12 chance. Now the thing is, a 1 in 12 chance occurs for drawing one ticket, but remember there are 4 $10 tickets. So what that means is, if I was to draw a $10 ticket, well, I have a 4 in 12 chance. Okay, so that's the probability of a $10 ticket. We figure out how many of them there are, so there are 4 of them, and how many total tickets there are. Well, there are 12. Okay. What about getting a $20 coupon? Well, there are 5 tickets, so a 5 in 12 chance of getting that. And what about a $50 coupon? Well, there are 3 of those out of 12. So let's build kind of a tree diagram. Here you are starting, you're about to pick, and you have 3 different options. You have option 1 is to get $10, option 2 is to get $20, and option 3 is to get $50. So that's in your first draw. You put your hand in. So we'll just let the colors kind of denote the prices here, because I don't want those numbers to confuse us. They're not really that important. What's important is the probability. Well, I have a 4 in 12 chance, I have a 5 in 12 chance, and then I have a 3 in 12 chance. Now, the second draw is where it becomes very, very different. Okay, so let's assume we take path number 1. Okay, and we get a $10. Well, what's the probability then of the next 3? Well, of getting another $10, this is where the information is dependent. I've already drawn one of the $10 coupons, so there is no longer 4 left. There are only 3 left. Okay? And not only are there only 3 left, there are no longer 12 tickets to draw from. Because we also drew one of those out, there are now only 11 tickets to draw from. So that probability has changed from the first to the second draw. Okay? The same idea kind of happens here with the $20. Now, there are still 5 of those, because in our first draw, we're still in this route here, okay? In our first draw, we didn't take one of them, so there's still a 5. But again, there's no longer 12 tickets to choose from, so it's a 5 in 11 chance. And then the same idea for the 50. We didn't choose that in the first one, so there's a 3 in 11 chance, okay? Now for our next one. Same concept. We have 3 different options: red, blue, green. Great colors. In this case, we drew a $20 ticket first. So that means there are still 4 $10 tickets, but it's out of a total of 11 options. There are actually only 4 more 20s because we chose one at the beginning in our first draw. So now there's only 4 in 11. And we didn't choose any of the 51, so there are still 3, but again, only 11 tickets to draw from. And then the final third of the tree diagram, we have, there's still 4 options out of 11, because we did a $50 ticket first. There are still 5 options out of 11, because we draw a 50 first. And then this is the one that really changes. Because we already drew one of them, there's now only a 2 in 11 chance. Okay, so these are all really the routes. You can do 10 first and then 3 different from there, a 20 first, then 3 different from there, or a 50 first and 3 different from there. That gives you 9 different options to come out with. Okay, so this would be the tree diagram, and each of these probabilities is a little bit different. The way you calculate it is by multiplying the first probability, so let's do it from the first tree, 4 over 12, times 3 over 11 would give you the probability of going 10, then 10. Going 10, then 20 would be 4 over 12 times 5 over 11. Okay, I guess I can kind of bring those up very quickly for us. Let me get my, well actually, so now the question's asking us to calculate the probabilities of the $20 certificates. Okay? And really what they're asking is what's the probability of having no $20 certificates in your first 2 draws. So first 2 draws. So in other words, we have to add up all the probabilities where we get no $20 certificates. So as you can see, we kind of calculated them here. This first root, the probability of having this specific root where you draw a 10 and then you draw another 10 is a 12 in 132 chance. The probability you draw a 10 first and then a 20 is a 20 in 32 chance. Now, keep in mind this would be a 10-20. What if you did a 20-10? That would be this root. You drew a 20 first and then a 10 second. You then still have a 20 in 132 chance, but the order was kind of important here because you know, think about if it's for different people. If I'm the first person draw, I get the $20. If I'm the second person, I only get the $10. It does make a difference. If you add up, and I know it's kind of condensed here, but each of these probabilities I have, you add them all together, the sum is 1 or 100%. All the probabilities should add up to 100% because we're encompassing all the possibilities in this draw. So, brings us back to here. Probability of having 0 20s. Well, I'll kind of highlight it. You're either on this root here or this root here. You're definitely not in the middle root in this question. Where is it? Because the middle root talks about getting a 20 as your first draw. So that's definitely not our options here. The roots that do allow that is if we get a 10 and a 10, or we get a 10 and a 50, or we do the opposite order. We go a 50, then a 10, or 50, then a 50. So as you can see, there are 1, where do I write this probability? 2, 3, 4 different probabilities where you do not draw a $20 certificate. So we need to add them all together. Okay, so I'm going to check them off in green. We have 1, 2, 3, 4. So we add those all together. So I'm going to write them down here in black. We have a 12 in 132 plus a 12 in 132 plus a 12 in 132 plus a 6 in 132. What's wonderful about adding fractions is our denominator is going to stay the same. We just got to add our numerators, which is going to be 36, 42. So we should have the probability of having no 20s is a 42 in 132 chance, not drawing any $20. Now they asked us for the probability distributions, which means they're also looking for what's the probability of choosing only 1 and what's the probability of choosing 2. So we'll do the 2 really quickly because that one's actually really simple. We'll do it in blue. Probability of getting 2 20s, well there's only one root where you get this 20 and then you get the 20 again. So that probability is this one. I know it's convoluted here, but it's this probability, that 20 in 132. We did 5 times 4 for the numerator and 12 times 11 for the denominator. So this one here is a 12 in 132 chance. And then really, this one is whatever the rest is. I can add them all up in our tree diagram, or I could take one and subtract this and this value, and that would tell us what this probability is. Because, again, all the probabilities have to add up to 1. But I'm just going to show you the roots, and I won't really calculate that one, but I'll show you the roots of getting 1. Well, the roots are you can get a 10. Oh, that's not a good color. Here we go. You can get a 10 and then a 20. Okay. You can get a 20, then a 10, or 20, then a 50, or you can get a 50 and a 20. Okay. So those are essentially all the other ones that are left over here. And their probabilities, I'll check them off, are this one, this one, this one, and this one. Again, I kind of convoluted on the side, but we would add them all together. So I'll quickly put it in. We have a 20 in 32 chance there. So 20 in 132. That's our first one. We have a 20 in 132 again as our second. We have a 15 in 132. And we have a 15 in 132. So that would give me 40 and 30. It should give me a 70 in 132 chance of having them all together. Is that correct? Well, I think I wrote this one down wrong. This should have been I think I said 20 but wrote down 12. So all these probabilities here, we should be able to put them all together and they should equal 1. Okay, just as a side note. So I'm going to do that on the side in green here. So I'm going to say all together. That's 42 over 132 plus 70 over 132 plus 20 over 132. 70 and 20 is 90. And 90 plus 42 is 132. So 132 over 132 is 100% chance. So that is essentially all the probabilities, just shown in a different light, in a different way. To continue that question, this question keeps going and going. What's the probability that exactly 3 of the first 5 prizes drawn will be $10 coupons? So at this point, we assume we know all the probabilities. The very first thing we have to figure out here is exactly 3. Whoops, that's not the highlighter I want. There you go. Exactly 3 of the first 5 prizes. Well, we got to figure out how many different ways you can choose a $10 coupon out of the first 5. And that's the idea of 5 choose 3. Okay, so that is actually the very first value that we'll need to multiply by the rest of our probabilities. Okay, if you take your calculator out, you'll find out that 5 choose 3 is the value of 10. Okay, so when that's calculated. So that's the kind of trick, that's the part that many people will forget to do in this question. The next step is we can find essentially the 5 spots. So we'll call this the first draw, the second, the third, the fourth, and the 5th. Okay, so there are 5 different spots we can draw from. So assuming that this guy counts for all the different possibilities, we just got to figure out all the probabilities. And remember, the probabilities are dependent. So I'll kind of bring our values back again. I think we had a 4 in 12 chance of a $10 coupon, a 5 in 12 chance of a $20 coupon, and a 3 in 12 chance of a $50 coupon. Okay, so because this combination has chosen all the different methods, what we're going to do is we're just going to calculate the $10 coupons as the first 3, and then we'll calculate the last 2, 4 and 5, as the other possibilities, because they're asking for exactly 3. Okay, so we can only get exactly 3. So the probability of choosing it as the first one, well, there's a 4 in 12 chance of choosing it the first time. So we draw it, we go in the bag, we have 4 possibilities out of the total 12. Of drawing another $10 one. Well, we've now reduced that number, right? There's no longer 4, there's only 3. There's also no longer 11, there's only, there's no longer 12, there's only 11 numbers to draw from. Okay, again, because it's independent. And again, we need 3 of them. Okay, I'm going to change the colors for the other one. Well, because we've again drawn again, there are only 2 left out of the 10 coupons left in the bag. And let's change these colors so we know that we're no longer doing $10 coupons. For the rest now, well, again, there's still only 9 and then only 8. The total number is always dropping in the denominator. But the numerator this time, that has changed a lot. We have to keep in mind that there was originally 12 to start, and we've drawn 1, 2, 3 of them out, and there's one more $10 coupon left. So we don't want to draw one of the $10 coupons. Well, because there's only one $10 coupon left, that means there is still 5 $20 and 3 $50. So there are 8 other coupons to draw from. So there's an 8 in 9 chance that we draw one of the other coupons. And it doesn't matter whether it's a 20 or a 50. And then for the 5th draw, that number is also dropped again. There's a 7 in 8 chance, right? Whether we chose a 21st or a 51st, this value drops by 1, and now there's a 7 in 8 chance. So to calculate this all, I'm going to write it down in black here. We have the number 10, because 10 calculates all the different ways, times 4 over 12, times 3 over 11, times 2 over 10, times 8 over 9, times 7 over 8. So this is a trickier question. You can go about, this 10 you can kind of write as a fraction. We can call it 10 over 1. And you can kind of calculate this all with your calculator, and they'll ask you to reduce the fraction. I'll show you a way, if you recall, because everything's multiplied, I can kind of start like eliminating similar numbers that are on the top and the bottom. So like there's a 10 here and there's a 10 here. Those can both become the number 1 now. I can eliminate those. There's an 8 here and an 8 here. That can become a 1, and this can become a 1. The only reason I'm doing this is so that I can do the multiplication kind of myself here. What other values can we knock down here? There's the number 2 and 12. 2 goes into 12 6 times, so I can turn this 2 into a 1, and this 12 into a 6. Okay. I can also reduce this 4 over 6 by dividing both of them by 2. This would become a 2. This would become a 3. And then I can reduce this 3 and this 3. This part here is not really that important. You could just use the calculator and multiply it. I just didn't want to bring out my calculator. I want to try to do this by freehand here. So I've done quite a bit of reduction. The numbers on top that I'm multiplying are 1 times 2 times 1 times 1 times 1 times 7, which really means I'm just looking at 7 times 2. I know that's 14. It's 14 over the numbers on the bottom. That's 1 times 1 times 11 times 1 times 9 times 1. Which means I'm really looking at, because the ones are important, 9 times 11, that's 99. So there is a 14 in 99 chance that you'll draw exactly 3 of the first 5 prizes as $10 coupons.